Algebra 1, Module 2, Algebraic Models. Lesson 2.1, Modeling with Expressions. Um, Once again, this is a recording after the fact, so why don't you go ahead uh, and try this if you haven't done so already. Okay, I assume that you pause the video and work this out, and remember this answer key right there, guys. And in case you don't have access to this, here are the answers. The main idea behind this is that the way we do the inequality is essentially the same as you do the equation with a one important exception, and that is not listed here, and we'll talk about that later, okay? Well, I'll tell you right now. Whenever you divide by a negative or multiply by a negative, you change the direction of the inequality. So, for example, like in this case, right, we added 23 to both sides, worked out nicely. In this case, we subtracted 14 from both sides to isolate the p. Nothing happened. So this is number 3. We multiply 5 to both sides to get rid of the 5 to isolate the variable n. So those are all very familiar, right? So something like this, for example, what if you had 2 minus 3n is less than, I don't know, 11. So you might subtract 2 to both sides, which will yield, on the right hand side, 11 minus 2 is 9. Here we have to divide by negative 3 to isolate it. If you do that, as soon as you divide, you need to change the direction. Therefore, the n is greater than 3. Question is why? Um, Generally, when I teach, I actually want you guys not to have negative values. In order for you to accomplish that, you might want to swap these two. When you do that, negative 9 is less than 3n. Now divide by 3, and you end up with negative 3 is less than n. If you read it properly, it says n is greater than negative 3. Same thing as here. So essentially, the reason why we change the direction of the inequality is that when we keep this positive, right, we need to swap places. So instead of swapping places, you just simply change the direction of the inequality. That's all it is. Okay. I hope that makes it a little bit more approachable. Okay, guys, and solving equation, that's review, and that's nothing new here. Here it is, number 8. See that right here, guys? Subtract 17 from both sides. 41 minus 17 gives you 24. When you divide by negative 6 to both sides, immediately you need to change the direction. So the h is less than negative 4. And once again, another way to think about that is to you swap places. So a great way to do this, instead of changing the direction of the inequality, you could just move the variables around to ensure that the variables are always positive. And once you do that, you don't really have to memorize that you have to change the direction. There's another way to think about it. Okay? All right, guys. Let's get started. Here are the notes. A bunch of definitions here, guys. An expression is a mathematical phrase that contains operations, numbers, and or variables. Terms is an expression. Terms of expressions are the parts that are being added or subtracted, and the coefficient is the numerical factor of a variable term. It's a just weird way of saying it's a number in front of the variable, right? And these are both numerical expressions and algebraic expressions. And the numerical expressions contains only the numbers, and the algebraic expressions contains at least one variable. So, what do I do? Okay, in this particular case, what are the terms? So this and this and this will be a term, and the coefficients are the numbers in the front, which will be what? 8, 2, and a 7. So it'll be 8p, comma, bad color. I'm gonna change to blue you don't mind. There you go. And then we got 2q and 7r. Okay. And then in this case, rewrite the expression using additions. Okay. So if you want to put in the plus in the middle, what do you suppose you could write here instead so that the expression is equivalent? If you said negative 2x here and negative 4y, you would be correct. Okay. In example C, there are $60 per adult to go to the amusement park, and they cost $30 for children. If A is the number of adults and C is the number of children, then the cost for A adults and C children is 60A plus 30C. What are the terms of the expression? Well, as before, it is 60A and 30C. So what are the factors of 60A? It's a 60 and A. Factors are things that multiply together. And I know some of you guys might have been tempted to say, hey, isn't that 2 times 3 times ... Yes. That would be called prime factorization, right? This book, it's just, they want you to know what major things do you have to multiply to get 60A. That'll be coefficient 60 and the variable A. Okay. And the next question, what are the factors of 30C? That'll be 30 and a C, right? So what are the coefficients here? Well, the numbers that are in front of the variables are 60 and a 30. Okay, let's keep going. Interpret the meaning of the two terms of the expressions. Okay, let me write that below over here, guys. That's it. There you go. It'll be 60A and a 30C. And then let's combine the two. What does that mean? What do you suppose the 60A means? 60 is the cost of the ticket for the adults. A is the number of adults going, right? So, for example, if there are 2 adults that are going, it would be $120 spent by the adults. If there are 10 adults going, there'll be $600 that have to be spent by 10 adults. So 60A represents the price of admission for adults, A adults. And 30C represents price of admission for C children. So when you add these two, it is total price of the two, right? All right. I already wrote it out in the lesson earlier, so let me just show it to you, because this is, after all, a quick summary. All right, here we go. So the 60 here represents the unit price, and that represents the number of adults. Multiplying that is the total cost for adults. Aha, made a little tiny little boo-boo. Yes, that should have been A adults and C children. All right. And then what is this equal to? Well, this total cost for everyone. I should have been a little bit more, what's the word I'm looking for? Exacting. That'll be total cost for everyone. That is A adults and C number of children. Sorry about that. All right, guys. Let's continue on with C. Yeah, it's just a lot of exercise in recognizing the parts of the expression. So this right here is an expression, right? 15 and 0.2b are the parts, the terms of the expression, right? Doesn't matter if you're adding or subtracting. What are the factors of each term? Well, 15 is the only term, so that'll be the 15. They didn't ask you to do prime factorization, so 15 is sufficient. And then what are the factors for the second term? This one, it consists of 0.2 and b. Do they both have coefficients? Answer should be, as we talked about in class, no. Because 0.2 is a coefficient, and 5, it's not a coefficient because it's not in front of a variable. A number by itself is called constant term. You could say constant, or you could say constant term. Hence, I wrote the term parenthetically. All right, so 0.2 is the only coefficient of the expression, and then in this case, the 15 represents the money, the dollar amount for the case of juice, and this here represents the total discount. Remember, I believe you get 20 cents per bottle. Yeah, 20 cents per bottle, and you have a B amount of bottles, right? So that is a total discount for having B bottles, right? So final price after the discount or simply discounted price. Okie dokie. All right, here we go. The next page in note. Curtis is buying supply for his school. He buys blah 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 blah. P package. Got it. So it's asking you what does that mean? Right? It's very similar to the previous question, right? That's another one over here. This one is slightly more tricky. Why don't you go ahead and try it if you haven't done so already. Okay, guys. So let me explain to you what we did in class. So let's look at A. The first part, right here, that represents the price of P packages of crayon. Because crayon costs $1.49 per package. The markers cost $3.49 per package, and there are Q of them. So $3.49 represents the price of Q packages of markers. So putting that together, right? Oh, by the way, whenever I have this cloud, it's a thought cloud. You could write them in, or you could just think it, because ultimately the question is asking, what is this? It did not ask you to describe what individual terms mean in great detail. So this was not necessary. But it is highly instructive, isn't it? All right, so this entire expression, because I'm adding this to individuals, must be the price, or you could even add the word total price to emphasize the point, to say that it's a total price of P packages of crayon and Q packages of markers. Okay. Part B will have slight variation on this thing because there are 8 more packages of inkjet paper compared to the P packages of jet laser papers, right? So in this case, this expression AP represents the price of P packages of laser jet paper, and this right here, this must be $6.95 per package. That's inkjet, right? So what that means is that there are 8 more packages for inkjet. So what that means is a price of P plus 8 packages of inkjet. So whatever amount of package you have for laser jet printer, you're gonna have 8 more for the inkjet, right? All right. So now that you thought about that, so what does that mean when you add them together? It is a total price of P packages of laser printer packages and P plus 8 packages of inkjet papers. Did I say packages over here? I meant to say papers. Okie dokie. All right, guys. Why don't you guys go ahead and do your turn, pause the video, play it when you're done. Okay, guys. Here are the answers. It's more the same. If you're absent and didn't really get this, then make sure you come see me during tutorial. Okay? All right. Next set of questions. You know what? This is a wee bit little tricky. But I would like us to try to do this. But to make sure that we're going the right direction, here's a hint. Why don't you just plug in some numbers to see if it works? That's always a great idea. All right, let's read the question, shall we? Suppose X and Y give the population of two different cities, where X is larger than Y. Sometimes when they give you this information, they're actually relevant. The fact that it's a population, I'm going to assume it's a human population, is that the number of population cannot be a fraction nor could it be a decimal. We cannot count half a human. So the number means it's a whole number. because it's a population. You can't have a zero population. If there's nobody lives there, it's not a city, right? So because y is a small number, this implies, along with this, that y must be greater than or equal to 1. Its smallest number is 1, but it could be larger than 1, right? Now the question is this. Which one's bigger? As the hint says down here, you could just make up a number, right? X could be 3 and y could be 2. If that's the case, in example A, x plus y is what? 3 plus 2, which is 5. Twice the x, which is twice the 3, is 6. That means 2x is bigger. Is there another way to do that? Absolutely. The way we can do this is that x is greater than y. So given information tells me that the x is bigger than y. Is there a way that we could use property of inequality, meaning adding both sides, multiplying both sides by the same number, or squaring both sides to make this happen? Well, we notice that one of them is 2x. The other one is x plus y. You know what? I have an idea. Why don't we add x to both sides of the equation? X is a positive number. Why not? Here's the thing though, guys. When you do that, the right hand side is x plus y. The left hand side is 2x. Because what we did here is perfectly legal and valid argument, right? And that x, we're told, is greater than y. So therefore the conclusion is 2x must be greater than x plus y, the question that we're asking. And that is it. Part B is slightly different. Okay. We know that since x is bigger than y, what do you know about y over x? When a bigger number is in the numerator, it's bigger than 1. Y over x, if the bigger number is in the denominator, it's actually less than 1. Because 1 is less than x over y, and 1 is bigger than y over x, it tells you that x over y is bigger than y over x. Okay? Is that consistent though? Okay, in xy, what is xy equal to? That's 3 over 2. Okay. How about y over x? Isn't that 2 over 3? Yep, that's bigger. So the conclusion I had is backed up by just me trying a different number. Okay. What we did over here is not a proof, or it doesn't even show that it's always true. But a random number that we picked happens to be true, right? So it just gives a greater evidence that it is true, but ideally this is the way we should do this. Okay? All right, guys. All right. And let me check out what's going on. I believe, if I'm not mistaken, we are almost done. Okay, let me slide down. Oh, there it is. Why don't you go ahead and try your turn 5, 6. Please pause the video. Okay, guys, let me show you the answer. Oh, before, if in case you haven't make a connection over here, this is incomplete because we're saying, oh, never mind. Earlier we said greater than equal to 1, greater than equal to 1, right? That's essentially the same thing. For a number to be greater than 0, and it is a counting number, a whole number, right? Therefore, I'm sorry, counting number is a natural number. A whole number includes 0. Here it does not. My bad. So counting number greater than 0 starts with 1. So this, 2, in the context of the question, is an equivalent statement. Okay? All right. So how do I deal with this? Well, Here's the answer. Once again, x plus y is bigger than x, right? Therefore, this is less than 1. X plus y is bigger than x. Therefore, this expression is bigger than 1. So that's less than 1. So therefore, x plus y over x is the larger expression. Okay. Another way I think some of you guys did was to just simply cross multiply this way and then compare from that point on. Okay. And that's what you see over here. I'm not a biggest fan of this one, but it's okay. It's too mechanical for my taste. Okay, another one over here is this is a book answer, obviously. The way I like to do this one is like I just simply give this to I'm like, hey, I don't know what's going on? Question mark. I divided both sides by x plus y because they're both a positive number. It doesn't change the direction, right? It says 2 x plus y, and it's a question mark. But here's the thing, though. What is the minimum number of smallest number for y? 1. Okay. X is supposed to be bigger than that. What's the smallest number of x? It's 2. Smallest possible number of x plus y is 3. It could be bigger, but 3 is bigger than 2. Therefore, x plus y must be bigger than 2 because its smallest number is 3. Okie dokie. Alright, guys. Alright. We gotta work on more definitions. I know. There's a lot of stuff to work on, but it's kind of nice that we're doing this. For those of you who are in this class, most of it should be fairly familiar, right? So it's good that we do this. Okay. So we want to know words that go with the addition. It's kind of a bit dry to say a plus b all the time. We want some variety, right? And some of those varieties that we have of the words to describe addition is the sum of, added to, plus, more than, increased by, total, together, and there's some of the more familiar ones out there, so I'll let you sort of think about it in your head. But I'm going to kind of use the ones that are not used as often, but by most people, or one that we'll be using a lot in the future, but that's not too obvious, like plus. Okay, and we have subtraction, less than, minus, subtracted from, difference of, take away, taken from, reduced by A, reduced by B, right? The multiplications are times multiplied by, the product of, the percent of. Yeah, this may be of for both of them, but they're used slightly differently, so we'll talk about that. And the division is divided by, division of, quotient of, divided into the ratio of. So if we have these expressions, how can we use these words over here to describe n plus 2? All right, instead of me writing from scratch, let me show you what we went over in class. All right, in period 2, I think I did it the same way. This one you could say number increased by 2. Instead of n, you could say number, right? The other is the sum of n plus 2, n and 2. You tend to write this in the order in which it appears. If it's 2 and n, like this, 2 plus n, we would say sum of 2 and n. Okay? Or you could say 2 more than a number. 2 more than n. Here's the thing though, 2 more than, so the thing that comes after than existed before the 2. So you have to change the order. So it's like, if it's n plus 2, when you write this, you have to change the order in which it appears. Okie dokie. It doesn't really matter that much when it's like addition, but in subtraction, it matters a lot. It has to be 2 less than a number right there. Okay? Because remember, you could change n plus 2 is equal to 2 plus n. That's okay. But n minus 2 is not 2 minus n. It's different. Okay? Be careful. So that's why we have to be respectful of the less than or more than. You have to respect the order. Um, yeah, well, typical ones will be n minus 2, like using this one. N, so 2 subtracted from n. Remember, the keyword here is from and a then, right? So that has a direction, which come first. And when we say difference of, we generally put it in the same order as it is shown. So it's n minus 2. In multiplication, we say product of, once again, when we say product of, sum of, difference of, quotient of, division of, we tend to write them in the order in which appears from left to right, top to bottom. So in this case, it'll be product of 0.6 and n. The one that we don't use as often, but sorry, I shouldn't say often, is not maybe so common. Maybe writing this number, especially if it's a decimal, writing that as a percent. So when you say 60% of n, that word of, that's the multiplication. 60% right there is equal to 0.6 or 0.60. Of is times n. Okie dokie. All right. So I put some variations of division. It'd be ratio of n and 5, quotient of n and 5, n divided by 5, or when you say divided by, simply use the symbol as well. Okie dokie. All right, guys. Okay, so we have, your turn. Why don't you go ahead, try this. Pause the video. Okay. So I'm gonna assume that you worked on it, and here are the answers, guys. Now, original price P, less means minus, right? And discount of 15%. By the way, to get a discount of 15%, you have to ask yourself, 15% of what? Of what? Is 15% of the price. That was implied. So that would be 15%, 0.15 of is times the price P. That's why we got that. And 1 minus 0.815 is 0.85. Okie dokie. When you fill something, you're adding. So that's the reason why we have a plus over here. All right, guys. I think that is it. All right, guys. Have a good night. Don't do anything I wouldn't do, okay? All right.